This is the lesson for Chapter 10, Section 40, and negative exponents, day number 2. And so today what we're going to end up dealing with are these prefixes on a power of 10. And so what we're leading up to is what's called scientific notation. And we'll start off with this first one. It says we're supposed to find the number of 2's in 10. And so this is to help us understand the concept of figuring out how many millimeters are in a gigameter. And so if we start off with something easy, you can see how the words here are pretty much the same type of words I have here. The only difference is here I'm trying to find just the numbers of 2 in 10, where here millimeters in a gigameter might seem a little bit more difficult. So number of 2's in 10. So basically what I'm trying to figure out is how many of these 2's end up making 10 if I combine them together. And so if I just have 2 of them, that is not enough. That's not going to be 10. If I have 2 2's, that would be 4, 3 2's would be 6, 4 2's is 8, and finally 2 2's, or 5 2's, end up making 10. And so what I could have done a little bit differently is I could have just taken 2 and think of what number times by 2 ends up equaling 10. And if I didn't know what that number was, I could use division. And then I could get 5. So it takes 5 2's to make 10. Well, we're going to be doing the same sort of thing here, except now instead of 2's into 10, we're trying to deal with millimeters in a gigameter. And so it says find the number of millimeters, and so we go up to our chart here, and it says a millimeter is 10 to the negative third of a base unit. And so the base unit is going to end up being like your meter, your liter, or your gram. And so all they're going to do is they're going to put a prefix in front of these words to represent how many we have. So if we're dealing with a millimeter, we've got a small distance. It's 10 to the negative third. It's 1,000th of a meter. And so you can see it's 1,000th because right here, 0.001 is 1,000th. And so it's 1,000th of a meter. And we're trying to go to a gigameter. So gigameter's up here. Well, a gigameter would be a billion meters, and so we have 10 to the 9th, and so this number right here represents 1 billion. And so we want to find out how many millimeters go into a gigameter. So we're going to do the same concept we did right here. We're dividing. We're trying to think of how many of those millimeters, so we're going to take a millimeter here, which is our divisor, and our divisor represents the number that we're dividing by right here. So this is our divisor as well. And we're going to see how many times it goes into our dividend. And our dividend, in math terms, is the number we're dividing into. So that is our dividend. And so we're going to see, again, another way to think about this is 10 to the negative third, which is a millimeter right here. See, 10 to the negative third is a millimeter. And we're thinking of what number that we multiply it by equals a gigameter, which is 10 to the 9th. And so what I'm doing is I'm dividing. See, that's why the millimeter is our divisor. And so when I do that division, I use the exponent rule. And so the rule says that if we have the same base, we can subtract the exponents. And so when I do that, I add the opposite, and I have now 10 to the 12th power. And so that's how many, find the number of millimeters in a gigameter. And so I would say 10 to the 12th millimeters per gigameter. And so that would be our answer. And here we are going from a megagram to a microgram. And so a megagram is 10 to the 6th, or 1 million grams. And since we're trying to find the number of megagrams in a microgram, the megagrams this time is our divisor. And so the microgram is our dividend. And so what we're going to end up doing is setting it up that way. Microgram right here is 10 to the negative 6th. And the megagram is over here, 10 to the positive 6th. And we're going to go ahead and do that division. And so that's going to show us how many of these megagrams fit into a microgram. And so we have 10 to the negative 6 minus 6. So when I add the opposite, I end up getting 10 to the negative 12th power. And so that's how many megagrams are going to be in a microgram. So megagrams in a microgram, and microgram is mu they use instead of an m, and so that's what it would end up being. And so if I wanted to write this with a positive exponent, that would be 1 over 10 to the 12th. So not too many. It's going to be a whole lot, just a portion of a megagram is going to fit into a microgram. It makes sense because a megagram is much bigger than a microgram, so it's going to be just a portion of a megagram will fit into that microgram. Now we're going from a picometer to a kilometer, and so we're going to divide by the picometer, and so it says that a picometer is down here 10 to the negative 12th, and so we're going to put that down in the denominator, and then our kilometer, which is 10 to the third, that is going to be our dividend. And so we'll put 10 to the third up here, and we'll do 10 to the third minus negative 12. Well, minus negative makes a plus positive, so we're left with 10 to the 15th. So that's how many picometers, and a picometer is just P, so let's fix that. So picometers in a kilometer. So that's how many would end up fitting in a kilometer. So we would have to measure out 10 to the 15th picometers to make a kilometer. Well, let's take a look at some other types of problems here. So we're going to use those same concepts with these problems, but this time, instead of using the chart, they're going to give us the information. So it says the mass of a deer tick is 10 to the negative 4th grams. About how many deer ticks did Ed pull off his sow if their weight, so their weight total, so this is like a total here. This represents what we are going to divide into, was 10 to the negative 2nd. And so this is just one deer tick. So the formula would look something like this. If I had one deer tick, and I multiplied it by the weight of of how many I had, so this is the quantity, would equal the total. And so that's what I'm trying to do, but I don't know, and they're asking me right here about how many deer ticks. We don't know the quantity, so what we're going to do is we're going to divide by that one deer tick. And so we'll divide it into the total. And so that's going to be our formula for this. And so we're going to set it up as the total, which was 10 to the negative 2nd grams, divided by 10 to the negative 4th grams. And when we go ahead and do this, we end up using that subtraction method, because we are dividing, so we subtract the exponents, we add the opposite, and so we see that this makes 10 to the, so add the opposite there, it's not a negative 4, it's going to become a positive because we add the opposite, so let's fix that real quick. So it was minus negative 4, so we add the opposite, and we end up getting 10 to the 2nd power. So 10 to the 2nd power, 10 to the 2nd equals 100. So 100 ticks. So the next one says a millimeter is about, or is 10 to the negative 3rd meters. And it says a flea is an external parasite that is 2 millimeters long. And it says some leeches are 100 times larger than a flea. We want to find the length of a leech in meters. Alright, so we'll start with the leech in millimeters, which is 2 millimeters long, and we're going to multiply that by what the formula is to change a millimeter to a meter. So if I multiply the length in millimeters times by 10 to the negative 3rd, that would give me the length in meters. And so from this point, it says that the leech is 100 times larger, so I need to multiply by 100. So what we can do is we can't multiply when the bases are different, can't change the exponents. But what I can do is I can take this 100 and change it to 10 to the 2nd and multiply it by 10 to the negative 3rd and then by the 2. These two I can combine because the bases are the same. So now I have 2 times by 10 to the negative 1st. And so now I can just rewrite this as 2 times by 1 over 10, and I just change this so it's a fraction, and then I go ahead and multiply cross. But I see some cross canceling that occurs. See, 2 goes into 10 5 times, so it looks like it's 1/5 of a meter. would be our answer. So 1/5 of a meter or 2/10 of a meter. Same thing. So let's take a look at the last problem. It says the mass of a proton is about 10 to the negative 24th kilograms. The mass of an electron is about 1,000 times less than a proton. Find the mass of an electron in grams. So let's start with the kilogram, and we know that a kilogram, we saw before on this chart, is 10 to the third. And so what we need to do is we need to change it to grams. And so they didn't give us the conversion factor here, but we need to know that. So 10 to the third times by 10 to the negative 24th. And this will give us the weight in grams of a proton. And so right now, we've got the weight in grams of a proton. We multiplied the number of kilograms in a gram, 10 to the third, times by the weight, or the mass of a proton, 10 to the negative 24th kilograms. Now it says the mass of an electron is 1,000 times less. Okay, so less means that we're going to use negative exponents. If it said more, then we use positive ones, but less means negative. So I'm going to end up changing 1,000 to a power of 10. And so the way I do that is just count the zeros. 1, 2, 3. And since there's 3 zeros, I'm going to multiply by 10 to the negative third. And that will give me 1,000 times less. And basically what this means is 10 to the negative third means that I'm going to divide. So I'm going to divide. Negative exponents means divide. And so we go ahead and continue. And when we combine these exponents, we've got this is negative here, we're going to go 10 to the third plus negative 24 plus negative 3. And the negative 3 will cancel out the positive 3, leaving me with 10 to the negative 24th grams is the mass of an electron. Now, they are the same, but remember, this was in kilograms. So if I wanted to find out the mass of a proton in grams, it would be 10 to the negative 24th times by 10 to the third. You see, that's 10 to the negative 21st. So this is the grams of a proton, and the electron is 1,000 times less. And so you can see how dividing, this one is actually bigger because it's negative exponents, so the one closer to 0 would end up being the larger one. So those are the types of problems that we're going to end up seeing on tonight's assignment. Good luck.